Hey guys, I told you I wanted you to kind of continue taking some notes today. Let's just pretend that this is me up at the Hovercam, and you'll write these notes as you normally would, and then there is a worksheet. I hate to call it a worksheet, like I guess an activity on a piece of paper that you picked up at the pickup table when you came in. Both of these things have to be done before you leave class today. If you don't finish the worksheet, then it's homework. Okay? Everything on the worksheet is really important. It's all fair game for quizzes and tests. Okay? So yesterday we finished up writing and naming acids and bases. I understand that that still might seem a little bit scary. There's practice on that on the worksheet. The sub has a key today. Okay, but we're not going to talk about writing and naming acids right now. We're going to move forward and take some more notes. Okay, there are two theories for how acids and bases behave in a solution. There's actually more than two, but we're just learning two. These theories are the Arrhenius theory and the Bronsted-Lowry theory. Okay. You don't know these definitions yet, so I shouldn't have you like already matching them with these definitions, but it's a nice way to just tell you what is what. Okay, so an Arrhenius acid is in a chemical compound that increases the concentration of hydronium ions, and that is just H plus ions, hydrogen ions. That is an Arrhenius acid. Okay. So anything that starts with a hydrogen is an Arrhenius acid. HCl, H2SO4, that's hydrochloric acid because it's a single element. That's sulfuric acid because it's a polyatomic that ends in 8 and there is no hydro in front. Anything that anything that starts with a hydrogen is an Arrhenius acid. An Arrhenius base is anything that ends in OH. Okay, so lithium hydroxide, calcium hydroxide. So you guys already know the Arrhenius theory because you already knew that anything that starts with an H you could consider an acid, and hydroxides are bases. Okay, so the technical definition of an Arrhenius base is a chemical compound that increases the concentration of hydroxide ions in an aqueous solution. That leaves Bronsted-Lowry acids and bases. Okay, acids for the Bronsted-Lowry theory are hydrogen donors, and bases for this theory are hydrogen acceptors. Okay, not all acids and bases start with a hydrogen or end with a hydroxide, so we needed a better definition. Okay, so the proton acceptors would be a Bronsted-Lowry base, and a proton donor would be a acid, Bronsted-Lowry acid. Okay, proton and hydrogen plus and hydronium all mean the same thing. Okay, so I try to mostly just use H plus, but if you see the word proton or if you see the word hydronium, it just means H plus. So let's just practice identifying some of these as either Arrhenius or Arrhenius acids or bases. If it ends in a hydroxide, it's definitely an Arrhenius base. Arrhenius base. Okay, so anything, go through and find any hydroxides. Those are your Arrhenius bases. Okay, anything that starts with a hydrogen is an Arrhenius acid. Arrhenius acid. So this is the theory. The Arrhenius theory is the one you already knew just from the last few days of talking about acids and bases. So again, just to reiterate, a Bronsted-Lowry acid is a hydrogen donor. Okay, it's going to give away protons or hydrogens. It will lose hydrogens. And a base, a Bronsted-Lowry base, is a hydrogen acceptor. Okay, that means it's going to gain a hydrogen. Remember, we can also call that a proton, because technically a hydrogen ion that's lost an electron is just a proton. So I wish I had had more examples of Bronsted-Lowry acids and bases in here, so we're going to have to kind of draw our own. Okay, so I'm going to give you a chemical reaction. Let's do H2CO3 plus water produces H3O plus and HCO3 negative. So this looks like really scary, right? Like, I don't know how to figure out who's my acid and base. And there's these other things called a conjugate base and a conjugate acid. So please write these down. Okay, if you need to take a moment and pause to get this down, that's fine. A conjugate base is the partner of the acid, and that will make more sense in a second. Okay, the conjugate acid is the partner of the base. Okay. Sorry, I just had my highlighters so I could color code. So your Bronsted-Lowry acid, its partner is the conjugate base. Okay, the Bronsted-Lowry base, its partner is the conjugate acid. And what I mean when I say partner is who did the acid give his hydrogen to? Who did the base accept a hydrogen from? Okay, so I'm so sorry. Someone's knocking on my door and I'm just going to ignore them. So your acid is the one who donates or loses a hydrogen. So what you have to do is find its partner. So what I do is, there's going to be a lot of H's and O's. Okay? You want to find the one element that's not your H or O. That makes it easy to find its partner. Okay? So these guys are partners. Right? Because I just found the carbon. There's too many H's and O's and you're going to get bogged down. But if you can find the random element, then you'll find your partners, the two that belong together. Okay, your conjugates. So we have to decide if this is your acid or your base. Okay, your conjugates are going to be over here. Your conjugate acids and bases are over here. Okay, so technically, you look at this and you're already probably intuitively understanding that this is probably the acid, right? Because it's an Arrhenius acid, because it starts with the hydrogen. But you just have to confirm that this is your Bronsted-Lowry acid and this is your conjugate base. So did this compound lose a hydrogen across the arrow? I have 2 hydrogens here and 1 hydrogen here, totally. So this is my acid. This is my conjugate base. That's the bell, it's lunch. Okay, so that means that this is my base and this is my conjugate acid. Remember, your base is conjugate, your base's partner is the conjugate acid. I hope you guys are writing all this down. This is important, okay? It's not in your note packet, but you are going to be held responsible for this stuff. Okay, so let me give you another example. I'm going to tell you that this is an acid. So what would its conjugate base be? Okay, acids lose, acids donate, so its conjugate is literally going to be 1 hydrogen less. Its conjugate will be H2PO4. Okay, now technically that's going to have a negative charge. I'm not worried about you remembering that. Okay, let's do a base. NH3. This is a Bronsted-Lowry base. What is it going to look like when its conjugate acid has accepted or gained the hydrogen? The acid is going to have another hydrogen. Okay, technically that's going to have a positive. I'm not stressed about you remembering that at this point. Okay, this is on the worksheet today. The sub has the key. Okay, Okay, this video is 9 minutes and 55 seconds long at this point, so I'm going to stop this and then I'm going to start a new one for neutralization reactions. So you're going to have 2 videos to watch. You have another one after this before you do the worksheet.